This video is on absolute value equations. I am solving these absolute value equations and checking my answers for extraneous solutions. So our first step is to isolate the absolute value. So I'm going to box up on this example of the absolute value, see if there's anything attached to it. There's nothing attached to it, so that means I need to look to see if I can continue doing this. This is equal to a positive. It's equal to an expression, so I have to continue it because the value of x could be different. So I don't know if this will be a positive value or a negative value in the end, so I have to continue. So the second step is to write out the equation as it is without the absolute value bars. So I'm going to have that x minus 2 is equal to that positive 2x. The other equation, we're going to keep the inside the same, so we're going to have x minus 2 is equal to, we have to take the negative version of this entire side, so it's a negative times that 2x, which is negative 2x. And now we solve. Solve for the x. So I'm actually going to subtract the x on this one. So we'll end up having negative 2 is equal to just x. So I have x is equal to negative 2. And on this one, I'm going to subtract the x. I'll have negative 2 is equal to negative 3x. Then I'll divide by that negative 3. So I'll have x is equal to, a negative 2 divided by negative 3 is a positive 2/3. But remember, we have to check our answers. So I'm going to draw my little line down here. We're going to check. So we have the absolute value of negative 2 minus 2 absolute value, because the x was negative 2, is equal to 2 times the negative 2. So we have to put that value inside everywhere we see an x. So we have the absolute value of negative 4 equals to 2 times negative 2 is negative 4. The absolute value of negative 4 is a positive 4. Positive 4 and negative 4 are not the same. So this is not correct. So the x equals negative 2 does not work. This is why we have to check our answers. So this will be an extraneous solution. So we have to check this one as well. The absolute value of 2 over 3 minus 2, absolute value, is equal to 2 times 2 over 3. 2 over 3 minus 2 is a negative 4/3. And 2 times 2 over 3 is a positive 4/3. Negative 4 over 3, the absolute value of this negative 4 over 3 is a positive 4 over 3. We have a positive 4 over 3. These are equal. Therefore, this one is good. What this means is we write out that x equals 2 over 3 is good. We also need to write out that x equals negative 2 is extraneous. Because we did get that solution, but it doesn't work. We do want to know that it is extraneous. The only solution that we would highlight, though, is the one that works. So we would highlight x equals 2/3. We do want to know that negative 2 is extraneous. So we still want to write that out. But the only one that would actually work, that would be your answer, is the 2/3. That's why I'm highlighting only that one. This is why we check for extraneous solutions. This next example, isolate the absolute value. So I'm going to box up this absolute value, and there's nothing attached to it. So I continue. This is equal to a positive number, so I can continue. So I take out the insides. I just take out the absolute value bars away from it. So I have that negative 3 plus x, all of that over 4 is equal to a positive 1. Then I take the inside again, it's that negative 3 plus x all over 4, and equal it to the negative version of this side. So it's a negative times 1 is negative 1. I'm going to multiply, so I'm going to solve. I'm going to multiply by that 4 to get it off the denominator. So I have negative 3 plus x is equal to a 4. Then we're going to add the 3, so we'll have x is equal to a 7. Do the same thing over here. I'm going to multiply by that 4. So I have negative 3 plus x is equal to a negative 4. Going to add 3, so we'll have x is equal to a negative 1. Again, the check. So we have absolute value of negative 3 plus 7, all of that over 4, is equal to 1. Negative 3 plus 7 is 4. So we have the absolute value of 4 over 4 is equal to 1. 4 divided by 4 is 1, so the absolute value of that is good. We'll do the same thing with the negative 1. So we have the absolute value of negative 3 minus 1 over 4. It's going to equal to 1. So we have the absolute value of negative 3 minus 1 is negative 4 divided by 4. Negative 4 divided by 4 is negative 1, and the absolute value of negative 1 is 1. So this will also work. So both of these are correct. So x equals to 7, and x equals to negative 1. This next example, again, we're going to isolate the absolute value, so I'm going to put a box around this. We have two things that are attached to it. We have a 5 and a negative. Now, when I have this negative is multiplied to it, but the 5 is actually technically added to it because it's a positive 5. So we want to subtract the 5 first, not do the negative, but subtract that 5. So we'll have negative absolute value of x divided by 2 plus 3 is equal to negative 1 minus 5 is negative 6. And again, we still have to get that negative off before we can determine if we can continue. We divide by the negative on this side, so we'll have the absolute value of x over 2 plus 3 is equal to a positive 6. Now that it's isolated, it is equal to a positive, so we can continue. If we could not continue, we would say it's no solution. So we're going to take this x over 2 plus 3 and equal it to that positive 6. And we'll have that x over 2 plus 3 is equal to the negative 6. So again, the inside never changes. To solve for these, we actually have to subtract the 3 first. So we'll have x over 2 is equal to 6 minus 3 is 3. Then we can multiply by the 2 to get it off the denominator. So x will equal to a positive 6. Do the same thing over here. We're going to subtract the 3, so we'll have x over 2 is equal to negative 9. Then we're going to multiply by 2, so x will equal to that negative 18. So we must check. Back in the original, 5 minus the absolute value of its 6 divided by 2 plus 3 absolute value should equal to negative 1. Now again, because we're going to be taking 5 minus a positive value, it could still give us a negative 1. So 6 divided by 2 is 3 plus 3 is 6. So we have 5 minus the absolute value of 6 is equal to negative 1. The absolute value of 6 is 6, so we really have 5 minus 6. 5 minus 6 is negative 1, so that one works. Do the same for the negative 18. We have 5 minus the absolute value of negative 18 divided by 2 plus 3 absolute value is equal to negative 1. Negative 18 divided by 2 is negative 9 plus 3 is negative 6. So we have 5 minus the absolute value of negative 6 is equal to negative 1. We have 5 minus the absolute value of negative 6 is 6. So it's just 5 minus 6, and that is also equal to negative 1. So that is also good. Both of these are good, and it's because we had to take 5 minus the actual value that we're going to get from this, which could give you a negative answer. So x equals 6 is good, and x equals negative 18 is good. So I can highlight both of those. I rewrote them in red because I needed to check them before I could say that they were good. But it's also so in case they are extraneous, I could write out that it is extraneous. I got the values, but if extraneous, I need to mention that it was extraneous.